at the beginning, we talked about using technology to really change the world in peace. We talked about Internet of Things. Everybody talks about AI, the power of AI, machine learning. Everybody uses that, but most people have no clue. And it's a very interesting and fast way of doing pattern recognition in any pattern. So I asked Manel. Manel, he's from Spain, Barcelona. He's a faculty in electrical and computer engineering. There's an endowed chair created. At that time was Príncipe de Asturias. La cátedra Príncipe de Asturias. Pero el príncipe ahora se convirtió en rey. Entonces él ocupa la cátedra de Felipe IV. Sexto. So his expertise is in AI, machine learning. So I asked them to bring it down. So we have a whole, we can connect the dots from the beginning to the most recent applications of AI.
Because I'm going to talk a little bit about the controversy that has been going on for a while, and it will continue, related to this tool that we have that we could use for good or for bad. So let's start with the inception of artificial intelligence. That can be seen an attempt to mimic the structure of a biological neuron through the introduction of the perceptron by Warren McCulloch and Walter Pitts in 1948, sorry. They proposed the first mathematical model for a neuron that was later modified in order to make it tractable and usable in artificial intelligence. Psychologist Frank Rosenblatt proposed the structure of the perceptron in 1958, which contains the fundamental idea that it's still in use today. The idea consists of an input structure of retina that collects the data, which is later processed to extract the information contained in it. And the third layer uses this information to perform a given task. The parameters of these layers are trainable, so the machine can actually learn how to perform a task without being programmed to it, but it learns from trial and error. Yeah. The research that was funded by the US Navy attracted social attention. And the New York Times published an enthusiastic article that said that that will be the first electronic device to think as the human brain. The perceptron was followed by the neural network. These structures needed a particular training, which is called backpropagation, that was independently introduced in 1971 by Paul Werwas and then in 86 by David Rumelhart. And that is the first breakthrough in artificial intelligence because it's a device that could solve nonlinear problems. These architectures that are inspiring the nervous tissue had modest and limited performance for several reasons. First, the training mechanisms were not completely understood. Second, the programming languages used to implement these algorithms, they were not adequate for the high level of abstraction needed to properly and efficiently synthesize and generalize them. And finally, the computers, well, the computers, they were really crappy. And so, in spite of these limitations, Yann LeCun in the 80s featured a quantum leap in the development of machine learning-based AI for image processing. In order to find the inspiration for that work, we have to go back to 1959, when David Hubel and Thorsten Wiesel first described the visual cortex in cats, a neural network structure that imitated the cortex model constructed with artificial neurons. The first functional image recognition machine was the so-called convolutional neural network, introduced by Yann LeCun in 1989. This network was successful in character recognition, 200 integers with unprecedented accuracy. This was the first one of a series of networks that were published, and then around 2012, and then they have an outstanding accuracy in classifying among images of 1,000 different classes with a huge quantity of images for training. At the same time, parallel computing achieved maturity, and parallel processing systems became available for the average user. The other fundamental factor for AI was the development of the parallel programming platforms, paradigms, and libraries adapted to artificial intelligence, fundamentally in Python. This boosted the development of artificial intelligence in a factor 100 at least. The previous approaches that we have seen, they simulate the structure of the brain tissue in a simplified fashion and work for visual recognition. But what's in it for language? Well, at the same time, recurrent neural networks were introduced as a model that went away from this structural conceptualization to take an approach based on the function of the brain, in particular, to reproduce the persistence of the memory. And they were first applied by Hopfield in 1982 to solve optimization. In 1997, alternate recurrent models are really introduced in 1972 by Jeff Hellman. They were used by Ilya Sutskever, a former student of Geoff Hinton in Google, to produce the first efficient translation machine that we have been used for a while. The next revolutionary step, though, of the evolution of the artificial intelligence that we are witnessing now is when researchers started to devise means to emulate not brain structure or brain function, but brain behavior. And this is what we are seeing now. So the present mechanism, what they do is to emulate what we call the attention mechanisms. And these attention mechanisms, they have been used for as language models and later for image, for visual recognitions. So these language models, they were the first machines to ever pass the Turing test, that test that tells me whether I'm talking to a machine or a person. So the idea of attention mechanism is pretty simple. When we gather information from our environment, we do not just take features of this scenario. What we do is to pay attention to what is important according to different criteria in our brains simultaneously, and we discard the rest. When this is applied to a neural network, it's called a self-attention mechanism. And this is the base of what we call the transformers. These transformers, they were first mixed with recurrent neural networks and later without them, just pure attention mechanisms. They were first introduced around 2014, and they are the fundamental structure of what we call the general pre-trained transformer, the GPT. Mm-hmm. The first attention-based chatbot released by Google, developed in 2017 and named Lambda, created a significant amount of controversy when Blake Lemoine, one of the engineers of the team that developed the chatbot, suggested that the machine may present signs that imitate consciousness. Something that was widely misinterpreted as him claiming that the machine was actually sentient. Not true, he never said that. Lemoine is an expert in the study of AI biases in order to detect them and establish mitigation or removal mechanisms for these biases. He was fired from Google. He was doing a study related to gender, ethnicity, and religious biases. In the course of his experiments, he asked what religion the machine would be if it was an official in Israel. And the machine answered, the only true one, the Jedi religion. That triggered in him a feeling that the machine was perceiving that the question was tricky and deflected with irony. Lemoine concluded that if the machine was not able to pass the Turing test, then we're good, it's not sentient. But if the machine is able to pass it, then we don't know whether the machine is conscious or not. But this machine, Lambda, was hardwired not to pass the Turing test, he said. His reasoning is actually based on his own spiritual belief and not in science, because there isn't. We don't know what is consciousness. We cannot verify it, right? Cogito ergo sum. I think, therefore I exist. I don't know if you have consciousness or not. So, but in reality, he was put on administrative leave, was fired basically because of his concerns about the ethics of Google. Private companies as Google train their systems using fundamentally Western data, written in English. And then we expose the population of non-Western countries to the outcomes of these machines, thus imposing on them our culture, values, principles, religions, which are different from theirs. This is what we call digital colonialism. It's very serious. And this is a red flag, a danger of AI in the hands of those who do not put ethics as their first priority. Now he is an independent AI consultant. In May of this year, Geoff Hinton, the godfather of AI, resigned from Google in order to freely speak about the risk of AI. He claimed that a part of him now regrets his life's work. He thinks that the computer models that we have now, they might be better than the human brain for certain tasks. And the idea of artificial superintelligence, new concept, might come very soon. AI has a huge potential and it can be used for the good of humanity, but it can get out of control, just as nuclear power. Joshua Bengio, this guy here, a second father of AI, is more specific. He says, AI can pass the Turing test and they can fool us into thinking that they are human beings, which can destabilize democracy through disinformation, since AI is basically in the hands of anyone. And AI can achieve levels of complexity similar to those of the human brain without the limitations of the human brain. So one of these machines can be smarter than we are. The machine could act in a way that we could not. And it could, for example, misuse legislation by finding loopholes more efficiently than the smartest lawyer. A hack to my lawyer friends. Bengio claims, I know. But you know what I'm talking about, right? Okay. So Bengio claims that a regulatory body for this and many more maybe unknown issues of AI is needed. He signed with Hinton and many other scientists a letter claiming a pause in the AI experiments. We have seen that before, but in a context which is more likely to be understood from an ethical point of view by the general public, which is human cloning. I perfectly remember all this controversy. It started in the late 70s. I was in middle school, and it became a discussion between fervent defenders of science in spite of the ethical implications of cloning humans and the detractors of cloning. In 1996, Ian Wilmot conducted the first successful cloning of a mammal at the Roslin Institute in Edinburgh. It was called Dolly, the Dolly sheep. That opened the field of research on stem cells, but also raised a red flag. Again, the human cloning could be possible. And research in stem cells and cloning was prohibited in many countries. Next year, in 1997, the United Nations declared human cloning against human dignity. Max Tegmark at MIT wrote an article in Time magazine a couple months ago, that warns the risks of extinction due to the artificial intelligence. After all, extinction happens. And our humanity, the Homo sapiens neanderthalensis, overlap with Homo sapiens with a 95% of probability during 5,000 years. And we prevail. And many scientists concluded that we prevail because we have slightly better cognitive abilities. So this happened. Regulations apply to biotechnology, and they should be applied to artificial intelligence too. For example, pharmaceuticals, they cannot release a drug if the Food and Drug Administration doesn't go to the tests and controls and filters to conclude, to make sure that the medicine is safe and useful. So AI companies, they should not release an artificial intelligence before the governmental agencies make sure that the AI is safe and useful. Many other concerns have been raised, all of them related to the ethics of artificial intelligence, gender discrimination, data privacy concerns, many others related to equity and justice. Also, there are concerns in education. There are tools that can be misused by the students and by the educators. Plagiarism, made up scholarly work, biased content, again, homework and exam cheating. AI is a powerful tool that will change learning and teaching forever, but it can be done the wrong way or the right way. Salman Khan, who started with the nonprofit Khan Academy in 2008, is developing systems to bring AI personal tutors for students. If AI is used in controlled environments and built with known and biased data according to regulations and ethics, a good thing is possible. What else can we do here? We are educators, so we can use AI to educate, but also we can educate to use AI to our children. We need to demystify AI. We need to explain to the public how it works and what are the advantages and dangers of AI in the hands of children and teenagers, the bad guys, politicians, and corporations. We need a generation that is able to use AI for the good of humankind. We screwed up with social networks and phones in the hands of our children. Let us not repeat our mistakes again.
Yeah.
Yes.
So back in Argentina, I work at an NGO that basically is a fact-checking organization, and we fight disinformation, and we are very concerned about AI. And we have been promoting some media and informational literacy projects, but also we have the other side that is basically to try to work with governments and platforms that, as you were saying, the case of Google, kind of like produce this kind of AI, and they apply it to their different products. But we face the challenge of not trespassing freedom of expression. So I was wondering, in your experience and everything you just mentioned, which were some recommendations that maybe you have for NGOs or people that are like academics that are concerned with this, how we can work with governments or platforms to try to create some regulations to try to make the use of AI the best way possible.
One of the things that I like of the field of research in artificial intelligence is that at the time I started with it, it was a democratic thing. So AI was there, published in papers, software was there. You could just download it and work for free, not work for free, but use it for free. And then we have big computers that are relatively cheap. We can use them, everyone, right? You can use them for profit or for non-profit, right? So the problem comes when private corporations start using them. One of the problems that I see, well, not me, many people, is that we have a lot of controls, filters, and regulations for AI in English. But if you are using an AI or anything that contains artificial intelligence in other languages, say Bengali, for example, you are totally exposed. There's no controls. There are no efforts to make artificial intelligence unbiased and free of dangerous content, like, for example, Nazi content, which is something that happened to Microsoft, right? So one of the most important things, I think, for the governments is to be able to produce these control mechanisms in a multilingual environment. So our children first, but then also our democracies, they are not threatened by uncontrolled biased content.
Great, thank you.
Yes.
Well, okay, so you mentioned super intelligence.
Yes.
You also used the term colonialism.
Yes.
Colonialism is a human construct.
Yes,
that may not pass the test of super intelligence.
exactly.
What would the super intelligent construct for the evolution of colonialism look like? Would it include humans?
Yes, so let's see. The AI is in nature not colonialist. We are. So yes,
An intelligent being is colonial. It's not necessarily restricted to humans, correct?
yes, but humans are the ones who throw the data into the machine in order to train it.
But in super intelligence, how do we train something that's more intelligent than us that trains itself?
How do we train something which is more intelligent than us?
We won't train it, it will train itself.
Yes, well, so there are two parts of superintelligence. First, the information that we use to train it, and then the complexity of the system that is trained. And so what is the advantage of our brain? Well, the super complexity, but what is the limitation of our brain that machines don't have? And this is what might make them more intelligent than its creators. Well, we are limited to language. We use language for everything in our reasoning. Well, that's our mechanism for communication, for abstraction. Machines don't necessarily use that. They analyze the language, right? And so and they use abstraction mechanisms that actually we don't even understand them. We don't really understand why and how the last chess player use artificial intelligence can win. We don't know, right? And so that is something that is more intelligent than us. So how long will it take for a person to read the internet? Well, it's computed that a person will need 10,000 years to read the internet. At present, a few years for a transformer. Right? And so the transformer can access all this information in real time without any difference between different groups of knowledge inside. And we don't have this ability. And so this is basically the concept of super intelligence.
Sure. Sure. So colonialism is something that we think about
Yes.
in our social constructs, for better and for worse. Right?
Mm-hmm.
But a super intelligent capability may see a very, very different way of evolving. That while we're concerned about it behaving better than us at what we do, it may believe that it wants to do something entirely different. It doesn't involve us.
Yes.
Interesting.
Not quite. So no, I mean, so partly colonialism in machines comes from bias. So if I put the knowledge acquired in one context in a different context, this is when things get worse. When the Spaniards went to America, what happened? The Spaniards, they didn't have the intention to kill the indigenous people, but they did. And so the problem with that was many of the problems that that they created. So basically produce partially an extinction of the indigenous people, but one of the problems was the bias that they brought. Among other things, they brought their religion, right? They brought a language that the indigenous could not understand, and vice versa. But it was not intentional.
Understood.
There's more questions there.
Yes.
No, we were saying here, we're discussing about your discussion, that we think that maybe sometimes we feel like technology as something that is like above us, and in reality, it's like a tool that we use. So I think, I don't know, it's my opinion, and maybe you don't agree with me, but I think that is the meaning that we put in those tools that makes things colonialist or not, or that makes something racist or not. I don't know, and I wanted to ask a question also. I don't know if I can. But I don't know if you want to say something. I wanted to ask you, because you said, you say there that we can educate our students in AI and with AI.
Yes.
And I work in the education field, and I work at an international organization that like sees education as something that is in all your life. So in all the sense of your life. So it's not only on your childhood, but it's also in your adulthood and on your elderhood. So I tend, and I don't know if it's only my approach, but I tend to see technology and internet in general as something that generally helps elders. So how can we educate elders in using AI?
That's a very good question. Yeah, so I think that we could teach AI to be adapted to the elderly. All due respect. So, well, my dad is 79, right? And so he has a hard time to use his cell phone for many reasons. First, he doesn't see. Then he has fat fingers. Then there are concepts that our children, they are born with. They are digital natives. I don't exactly know if this is the right, but my dad is analog, right? So the problem with these phones is that they are not adapted to them. But the smartphones, what we call the smartphones, they are not smart at all. They don't have anything inside that is smart. AI is smart. And so this is a tool that we can use to adapt itself to the elderly. Teaching the elderly about artificial intelligence, well, from an abstract conceptual point of view, I think that we can explain to the elderly what it is, the same as the rest. But from a usage point of view, I think it should be all the way around. Sorry, the other way around.